this slide. I just want to quickly also mention our digital archaeology research group back in Leiden and what we do, just so you got a little bit of context. So teaching, we've got an MSc in archaeology. It's a focus area in the MSc of Archaeological Science, currently called Digital Archaeology, but we're currently rebranding it to Computational Archaeology, going a bit more towards that side and everything digital. And yeah, so 28 MSc theses, 2 PhD dissertations since 2016, and it's currently led by Karsten Lambers. And then our research is fairly broad. We've been involved with interdisciplinary research program on data science and artificial intelligence, and yeah, using computational methods to derive archaeological information from large bodies of digital data is what we're well focusing on and like to be known for. With the focus areas of remote sensing, so this is stuff mainly my colleague Wouter School-Vaart has been working on, myself text mining, and then I've got a couple of colleagues also working on modeling and simulation. And this bar just keeps popping back up. That's very annoying. Maybe I'll move it down. Can we get out? That might be slightly better. Try and hide it. Okay. Oh, I have to click OK also, right? So many, yeah. So just briefly, I always put the slide in when I'm presenting abroad. Excavation in the Netherlands. I think this is fairly similar to the UK situation. So we have both research-led and development-led excavations, with the research-led being limited in scope, so there aren't that many of them, especially in the Netherlands. And these tend to be done by universities and heritage agencies. And yeah, and then of course there's a lot of development-led excavations as well. These tend to be done by commercial companies and are the vast majority of all excavations. And we've seen a sharp increase since the Malta Convention in 1992. And so, yeah, all these development-led projects produce reports. And so this is a large portion of the archaeological activity in the Netherlands, and it's similar in the UK, I'm sure. And it's a, yeah, random, in brackets, sample of the archaeological record. It's not completely random, it's very much determined on where we're building, but it's more random than the theory-led research, at least. And so in the Netherlands, we call this the Oogst op Malta, Malta Harvest. And our heritage agency is in that scheme, sort of trying to synthesize all this data together from all these different excavations. So the problem is that these reports are unpublished or grey literature, as it's called. And the majority is archived at either our National Library or the DANS archive, very similar to the ADS here. And currently the search is on the metadata and not the full text, which I'll come back to in a moment. Which means that the bycatch is not findable. Again, something I'll explain in a moment. And because of these problems, these reports are sort of underused because it's just hard to get the information that you need, which means that people, well, don't do it or do it to a limited extent. And so these reports, the numbers are growing fast, real fast. So at the moment, we've got about 80,000 of them, and they're growing by 5,000 to 8,000 a year. That's what we're seeing here, basically this graph. Malta Convention was around here somewhere, and then suddenly everyone started handing in the reports because they had to. So yeah, that's actually enshrined in law, so that helps us to actually get all this data at least into an archive, so it's available, but not yet findable. That's sort of where this project comes in. So I think we're all, well, as academics, we're all familiar with this problem that you go to a library, although it doesn't tend to be a nice physical library like this nowadays. But out of all these 1,000 books, there's only maybe these 2 that we're interested in. And of course, finding those 2, that's really what we're trying to do here. And that's where text mining can help us. Yeah, so coming back to the online archiving, so all these reports are in the DANS Easy repository. That's sort of what it looks like. We've recently rebranded. This is an old slide. Don't judge me. And so this archive stores them as PDF indefinitely in open access. That's great. Now let's click on it again. Yeah, there we go. And so the search is possible on the metadata. And so with the metadata in this case, I mean the title, some keywords that people add to the report, and the description, which is just free text. But yeah, the problem comes in when you have what we call the bycatch. So this is when you have, for example, a Roman site within one corner you find one Bronze Age find. Now, this Bronze Age find is not going to be the title, because the title will be Roman, blah, 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 and blah, blah, blah. In the keywords, well, it wasn't that important, so nobody added it. And in the description, of course, it's only 100 words or something. You're not going to mention that one Bronze Age find. So basically, currently, if you type in Bronze Age into this bar, that particular site won't come up, even though that is, of course, could be very important to your research if you're looking for Bronze Age stuff. One way we can solve this quite easily is by using full text search. This is very similar to what Google does. You type a word in and it will find any mention of that word anywhere in any of the documents. In the case of Google, that's of course the whole internet. In this case, we mean all the PDFs of these reports. That would already be a huge increase in the efficiency of the search. And actually, DONS has been implementing this, and a couple of months ago actually implemented that in their search engine. So that already is a big step forward, but it doesn't account for synonymy and polysemy. Now, unless you're a linguist, you probably know synonymy, maybe not polysemy. I'll just quickly explain what I mean with that, specifically in the archaeological context. So synonymy are multiple terms that have the same or similar meaning. So the Neolithic is also known as the Stone Age, but also 3500 BC falls within that, in the Netherlands at least, or 5000 to 4000 BP, or the 4th millennium BC, and so on. There's probably thousands of different ways you can express a time period within the Neolithic. But of course, if you're looking for Neolithic stuff and you type in Neolithic, you want all of these. You want all of these to be returned in your search results. But yeah, what Google does will just give you anything where it literally says Neolithic, but not these other ones. Although it's getting better, but not that good yet. And then the other way around, we've got words that a single word that has multiple meanings. That's polysemy. So for example, Zwifterband is a time period also in the Neolithic, but it's also, that time period is named after a specific pottery type, which is also called Zwifterband, which was named after the excavation, which is called Zwifterband, which is in the place Zwifterband. So basically, when you say Zwifterband, you could mean any of these four things. And of course, in human language, you know from context which one you mean. But if you type in Zwifterband into Google, it will just give you a map of how to get there. It doesn't understand that you might mean the pottery type or the time period. So one way to solve this polysemy is by applying named entity recognition, or NER. And basically this computational method that goes through text and finds and highlights specific concepts. In this case, it's found Zwifterband, the place, it's found flint, the artifact, and Iron Age, the time period. And basically what you see here is what the students have been doing for the last couple of days, clicking on these words and saying which one it is. And so once you've done this, the computer will know what is what. So in this case, it will know that here we mean Zwifterband, the place, and not the time period. And here we mean the artifact flint, and not, for example, Mr. Flint. So here we're trying to solve this problem of, okay, which meaning of the word do we mean here? And once we know that, we can then search for, I want all the Zwifterbands where it's a place or where it's a time period, whatever. So just to formally define what NER is, also more from a machine learning point of view and a computational point of view, is basically we have a sentence or a piece of text, and for each word we want to assign a label or make a classification for each word. Words also called tokens in this context. And so either we want to say a word is nothing, it's not one of the categories we're looking for, or it's a specific entity type. And so we're looking for materials, artifacts, time periods, so species, that kind of stuff. And so here we've got nothing, that's nothing. We've got stone, that's a material. We've got axe, it's an artifact, and then Bronze Age, which is a period. And so, yeah, this is from a machine learning point of view. We're doing classification on word basis, on word level. Now, there's different ways we can do this. First of all, is rule-based. Which I'll explain in a moment. Then there's classic machine learning, which is stuff we've been doing for the last 50-ish years. But then deep and transfer learning came in about a decade ago, 15 years ago, started to be really used, which is another way of doing it, which is a bird model, it's called. And then I will be talking about the generic model, but also archaeology specific models, and see what the difference is between those two. For rule-based identity recognition, this has actually been going on for I think 20 years or something, like the Archaeology project, if you are familiar. And this was doing some rule-based NER in the gate architecture. And this is work by Andreas Friedrichs. And so he used the gate software to do rule-based NER. And the great advantage of this is that you don't need any labeled data. So all the stuff students have been doing today, clicking all these words, you don't need that at all. So you can save a lot of time by using this, which makes it very quick to try out. And so how this works, you basically create rules to try and do this task. So for example, you can do a vocabulary check. If X is in my vocabulary, then I will mark it as an artifact. And then also you can add some patterns or some rules. For example, if I have 1 or 2 numbers, and then after that comes century, so like 1st century, or no, that doesn't make sense. 6th century, then we can mark it as a time period, for example. And so by making some of these rules and checking some vocabularies, you can quite quickly extract some useful information. And generally this works quite well. And definitely when we're talking about words like axe, but if you're talking about a word like Flint, where it could be Mr. Flint or the town Flint, then it also already becomes a bit more complicated. So yeah, so there's conditional random fields. It's just a specific machine learning algorithm. Don't need to explain in large detail. But basically this is what is called classic machine learning or non-deep learning. And this is supervised learning, and that just means it's supervised, so it needs labeled data. So this does need the data that these students have been annotating for me. And like other machine learning classifiers, it's quite similar to other machine learning classifiers, such as support vector machines is quite well-known ones. Decision trees are also, it's similar to that, but the great thing about conditional random fields is that it takes context into account. So it looks not only at the current word, but also words around it. And that's really the step up from other machine learning algorithms. And this, well, it used to be the baseline for identity recognition. So this is always the thing you tried first, although it's been somewhat overtaken by a package called Spacey that does some more complicated stuff behind the hood, under the hood. And then finally, we get to, well, the exciting stuff for most people, deep learning. And so the specific architecture we use is called BERT, and that stands for Bidirectional Encoder Representations from Transformers. I always have to read it because I always forget the exact acronym. Yeah, and it's BERT, obviously, from Sesame Street. And actually, there's a whole load of these architectures that are all called, they're all named after Sesame Street characters or Muppets. There's also Big Bird, there's Elmo, there's all of these, yeah. So this is a deep learning technique. What that means is it's a bit more computationally intensive than these other methods I've been explaining. So you need like a decent GPU for it to run. And this was developed originally by Google. And luckily, this is one of the things that they did open source, so we can all use it. So it's very nice of them. And it can, learn the language. I put this in quotation marks because it doesn't really learn language, but it learns statistical relationships between words. And it does that by looking at large amounts of data. And when I say large amounts, I mean at least 50 to 100 million tokens or words. So this is like a large collection of words that you need to feed into it. And then once it's learned the language, you can teach it to do certain classifications. In this case, do an identity recognition by giving it some human labeled data. So this large amount of data is unlabeled. It's just text wherever you can find it. This needs to be specifically human labeled. And BERT used to be the big thing like 3 years ago, and then ChatGPT came in, or GPT-3 came in, and sort of changed the scene. It seems to be going really fast, so I wouldn't be surprised in 2 years there's something else that's even better. But weirdly enough, BERT is still really good at doing identity recognition, while these GPT models are still struggling with that a little bit, especially in languages such as Dutch and basically non-English. So these BERT models, so Google brought out a multilingual model, which includes Dutch. So most of the stuff I'll be talking about here is stuff in Dutch. For English, we're still actually making the data. So it's a multilingual model that contains 107 languages, I believe, including English, Dutch, and most of the Western European languages. And there's also language-specific models. There's BERT-based, which is just English. There's BERT-based German, which is German. and Bertje, which is Dutch. And then what we've been doing is making archaeology specific models. So the thing is about these models tend to be trained on the internet, open source books, whatever they can find, but it doesn't tend to be that much archaeology knowledge in there. So for the Dutch one, I believe there's 15 pages on Wikipedia about archaeology, which is not a lot of sample size. So what we did is we took each of these language specific models, and then we further pre-train it with large amount of archaeological data. So it's already seen all of the internet, and now we're saying also look at, for example, all of the ADS documents for English, or all of the Dance documents for the Heidelberg Library for German. So basically what we're trying to do is we take a bird and we make it into archaeologist. We're not done yet, so it knows archaeology, but it still doesn't know how to do named entity recognition, and that's where, again, this training data comes in. So we fine-tune it with label data to train it to be able to do named entity recognition. And then we can extract entities and calculate the performance and see how well it's doing, which is, yeah, always important. So big table with all the results. I won't go into too much detail. Don't worry about precision and recall unless you're really into that kind of stuff. But the F1 score is basically what you need to know is an overall measure of how good this model is at doing a certain task. And so what we see for each language, so this is Dutch, German, and English, is that always the archaeology-specific bird model is performing the best. And so, yeah, we see rule-based is generally the worst, but then comes CRF, then we have the general bird model, and then the archaeology bird model improves upon that again. So this basically shows that these bird models are good, but they can be improved by giving them specific information about the domain you're working with, in our case, archaeology. Also an interesting thing to note is that the increase in performance for Dutch and German was larger than for the English model. So here we see the increase is about 1% point, while here it's about 3% points. I think this is, yeah, there's a couple of options. One is the English model is just bigger in general. It's seen more data because there's more data available in English. Also, it could just be that in Dutch and German, it's just harder to mark these entities. Or it could be something to do with the quality of the annotation data. So not sure yet. We need to investigate a little bit more. Yeah, also something that's interesting is that these bird models are what's called non-deterministic. Basically, what this means is that if you run them twice, you don't get the same output. So it's not like a formula where one thing goes in, and if the same thing goes in, the same thing comes out. Sometimes they vary a little bit due to randomness in the process of how they're trained. And so that's unlike rule-based stuff, which is just very deterministic, and also CRF4 is always the same stuff in, same stuff out. But here is some variation. And so what I'm trying to show here is that this is the multilingual model, this is the Dutch model, and this is the Dutch archaeology model. And we see that the variation in how well they're doing becomes smaller the more specific a model is. So this also shows you that the model is not only getting better, it's also getting less varied in its answers, which is good to see. Because it means eventually when we apply it, it will hopefully be more accurate. Doesn't matter how we run it. And yes, something I found quite interesting is to look also into the errors it's making. So this is on the Dutch archaeology model, Archaeology. And so this is a confusion matrix. You don't need to look into it in detail. But I think what's interesting, what we do need to know is that this is basically the true label. So this is what a human has said it is. And this is what the bird model thinks it is. And so what we see here is it makes a confusion between materials and artifacts. And this is actually something that humans do as well. For example, if you say pottery, we'll think, oh, it's probably an artifact. But if you say, or actually flint is an artifact, but you can say something's made out of flint and then it's a material. So some gray area there. Also confusion between context and artifacts. Again, you might have big artifacts like an oven or something, but also can contain artifacts. So is it then a context? Or like a big canoe or something is technically an object, but it can contain stuff. So that's where mistakes are made. And then also between species and artifacts. I think this probably has to do with sort of when you say horse bones, and then horse gets included with the bones as an artifact. And so it's, but these are also the same sort of confusions I got the most questions from when we were annotating. And so the confusion, if you want to say, of human annotators is translated into the model, and it's making the same mistake. So this is sort of what we expect to see, and good. It would be weird if it was making all errors around here somewhere that I can't explain from a human point of view. Yeah, then of course ChatGPT came in sort of right at the end of my PhD, and it was too late to actually do anything with it. So that was, and actually BERT already came in halfway through my PhD, so I had to already pivot. So that was basically in the 4 years of my PhD, we've had 2 big paradigm changes in the way we do this. So it's hard to keep up sometimes as a non-machine learning expert, but I'm doing my best. So this is ChatGPT 3.5, I believe. It's already outdated. We've got 4.0 now. So I tried to do some NER, and it missed actually the pot. So it found the bronze axe, but not the pot, which is a very clear artifact to me, but it couldn't find it for some reason. Also, I wanted it in a specific format. If you remember these O's, and for each word, I want like a label. So these O's are generally okay. Then we get stuff like misses the pottery again. So yeah, it's me very clear that that's an artifact, but not ChatGPT. And then when I do it in Dutch, it's just terrible. We get things in time periods and time references. There's artifact counts. It's missing stuff. And this is definitely a problem with these ChatGPT models, that they tend to work very well in English because there's so much English data available both on the internet and in books and stuff. But on what we call low resource languages like Dutch and any language that's basically less spoken, they don't tend to work that well. Now, I haven't tried this yet on the latest ChatGPT version. It's probably all better now, but yeah, I'll try that at some point next week. Okay, so now, so we tested the archaeology specific BERT models, and now I applied it to my entire document collection, so all 80,000 documents. And this is basically just a table showing you what we found. So in total, 13.5 million entities. Yeah, and you just see some examples there. Artifacts, pottery, charcoal, this is the kind of stuff I expect. Pits, ditches, post holes, sure. Wooden flint for materials. Yeah, these are all, so if you speak Dutch, very common locations. Species again, time periods all make sense. A couple of weird things is this apostrophe. Not sure where it came from, but then when I started thinking about it, there's some place names in the Netherlands that start with an apostrophe. So the Hague you're probably familiar with, but you can also say Schravenhaven, and then you started with an apostrophe. So I think that's what's going on there. And the time periods, we have this very specific date of 150 to 210. I'm assuming AD. And I didn't really know what it was because nothing really happens there. It's sort of like end of the Roman period. It's like, not sure. So looked into it, and I realized this is actually the grain size of medium coarse sand in nanometers. But what was happening is basically, this is shown generally in these coring reports. And it's just, yeah, in a table like this, to us, this makes sense because it's in context, right? But when you extract this to plain text, just on its own line. And so this BERT model just sees 150-210 and no context, and just assumes, well, that's probably a date. And I think most archaeologists would also do that. If you present them just with this bit of text and say, what is this? They'll be like, probably a date, right? Makes sense. Yeah. So that's what's going on. And I think there's actually no way of fixing this without pre-processing. So I might need to remove these tables from the data before we even show it to BERT. Yeah, so going back to an earlier slide, of course, I said the polysemy we can kind of solve with named entity recognition, but I've not really talked about the synonymy yet. There's a problem with all these time periods that could be similar in meaning. And so how we try to solve that is by extracting year ranges. So every time period that BERT finds, I need to calculate back to a year range. And so we actually use a rule-based script. So do, for example, if I find the word Neolithic, check it as thesaurus, I calculate it back to what the date range is. Yeah, and then all these different types of expressions of time periods, I just want to turn them into actual numbers, because then we can compare them and just search on the actual time period, not by name. but by date, basically. And that seems to work relatively well in the search engine, which I'll show in a couple of minutes. But before that, now we have all the time periods as numbers, so we can make it into a graph. That's always nice. So yeah, this is the graph that comes out when we just look at basically all the archaeology of the last 20 years in the Netherlands. This is roughly what's going on. What I kind of expected was a line going low to high, because yeah, generally low, like newer stuff we find more of than older stuff due to all sorts of reasons. But apparently there's got a lot of stuff going on in the Neolithic that we're finding. Not so much Mesolithic, not so much Bronze Age, and then here we do see that sort of increase of more modern stuff showing up. Middle Ages, we do find a lot more late Middle Ages than early Middle Ages. This is like a really abrupt sort of jump. I think this might actually be partly also due to the way we describe things. Sort of the late Middle Ages is just mentioned more. Modern stuff we clearly don't care about, because we sort of mentioned, yeah, there's some modern stuff, we threw that to the side. And I think most of these actually are probably actually dates from references. Yeah, and then here, this giant peak, that's the 150 to 10 I was talking about earlier. So it's really skewing the data, like not a little bit, but it's visible there. And I wouldn't be surprised if some of these other sort of peaks are also to do with just wrongly found time periods. Yeah, and then so finally we actually get to the end product of what we're trying to build, and that's the search engine. It's called ACNES. Stands for Archaeological Grey Literature Named Entity Search. So this is where we use the Dutch archaeology-specific BERT model, extracted all the entities, and then we indexed it into Elasticsearch, which is an open source search engine, so we didn't build that from scratch. And then we indexed 80,000 of our documents. And if you want to have a look yourself, it is well, in Dutch, so it might be tricky, but it's at acnesearch.nl. So when you open this, hope it's sort of visible, you can search on the left, stuff on the right, and basically what I'm searching for here is every cremation, or looking for cremations between 500 and 750 AD. And so that's the early medieval period in the Netherlands. That then gets you some results. I've also got a map, so you can have a quick look of where these things are found generally, or at least where the search results are coming from. Yeah, most of the data in our project actually has some XY coordinates, but there is also always some missing. If you scroll down, you get sort of the standard snippets that you would see in Google. You get the little bit of text with the search term highlighted. You can look at some metadata if you want. And then if it looks interesting, you can also have a look at an actual preview of the page where this that has been found. So it's actually highlighting here all the cremation stuff, and it's mentioning early medieval right there. So this is just to quickly have a look at what does the page look like, what's the context, is this actually what I'm looking for? This is not downloadable, so we don't provide any actual data. That's just done by the archives themselves. So you can click on download PDF in the archive, which then takes you, in this case, to our heritage agent that holds the actual PDF. That's this way we don't have any problems with copyright and access rights, because that's not something we want to deal with. These early medieval cremations, we actually did a case study on it. This is work with Femke Lippok from Leiden University, one of the PhDs there. And so what up until this point was sort of assumed by the majority of people is that when we go from the Roman period to the early medieval period, we go from cremations to inhumations. Basically, it's a sort of hard cut, and then it's just inhumations from that point onwards. And Femke, from looking at the literature, already had an idea that actually this might be a little bit more nuanced. There might also be some cremations in this period. So Femke created a couple of keywords and queries to see if we can find these, and then manually check the results to see which ones were relevant. And then crucially, we compared this to an expert's knowledge, and this was both our own work and the work of the supervisor, the professor of early medieval history at Leiden. So they already had a database of every early medieval cremation they thought existed. And so what we found is that we got 30% more of these early medieval cremations than were previously known. And a lot of them were actually this bycatch. So this was sort of a Roman excavation, and in one corner was also an early medieval cremation. And also we found them in unexpected areas. On this map we've got the red circles are known cremations, and the blue squares are new cremations. So the red stuff is all over here, but then we actually found some blue ones also in this province and on that island, and that those weren't known at all. So that was an interesting find. Yeah, and then of course what this is doing is it's changing our views on the pure burial practice of that period, slowly at least. Yeah, and so that's really what we're hoping to achieve for this kind of search, to make this kind of research possible and feasible. Because of course, in theory, you could do this manually, but then you have to go through 80,000 documents by hand, and that's the thing we want to prevent. So in the project is called EXALT because we had to come up with a new acronym for a new project to get new money. Excavating archaeological literature. What we're trying to do is we're taking ACNIS. It will still be called ACNIS, but we're improving it in a 4-year project from early in the last year. So it's got a little bit of work to do still. And so we're adding more languages, English and German. So English, that's what the students have been helping me with this week, which is great. And we've done a similar workshop in Germany also, where we also now have training data for German. And then we're also adding more document types. So initially this was just for field reports. Now we also want to add articles and books and theses and basically anything that's sort of to do with the Dutch archaeology or the surrounding areas that we can get our hands on, we want to include. So we're also trying to harvest stuff from like Springer and that kind of stuff, which is tricky, but yeah. And in total, we're hoping to get over 200,000 documents. So it's quite a substantial body of work. Yeah, and then the end goal where we want to go towards, so I've not really talked about this multilingual aspect, is that we want semantic search through multiple languages. And so ideally what we want is that when you type in Neolithicum, which is the Dutch word for Neolithic, and that you will also find the Neolithic spelled in English, but also knows that like Hembury culture falls within there, and 4500 before BC, and also German terms like the Kugel and Foreign Kultur. Can't speak German, probably butchered that, but probably no German speakers. Yeah. But this is what we want to do basically. Really, when you start typing, that it starts to understand what you're trying to ask, and then get results for anything that's sort of related to it. And hopefully this way we can find information more quickly. And that's everything we've got for today. Thank you.
Oh, thank you so much for that. Really, really interesting. And does anyone have any questions? Come on.
I have actually seen Alex
Yeah. Thanks.
I just wanted to know what were some of the challenges you dealt with. Yesterday, you and I had a chat. Because for those of us in working, where people or really had that problem. One of my students working on something that's trying to put it's my way. So I don't know if there's a problem there. But what do you mean with that? Because see, unlike in your case where another part of when you have extracted development projects where you have rules and regulations, you must submit reports. The back end, other part was that tool. Methodologies from this process. The only obligation So that data is kept in this from and really doesn't really. So
Yeah.
I don't know how to answer the question, but I'm trying to understand what
Yeah.
I think issue about people, scholars leaving their data because you haven't given this volume of data or you didn't have access to this, it's really difficult to. I don't know what you can say to that.
Yeah, no, it's a very, very good question. And I think this is, data needs to be accessible before we can make it findable. But I think that, so we do run into this problem a little bit when we're dealing with German documents. So a lot of the German field reports are stored in local, like their provinces, like the Landesamt, they have individual offices where generally these reports are stored as hard copies, just in a cabinet somewhere. And yeah, even finding them is very hard, and they also don't want to give it away or similar, maybe not to that extent, but there's still some resistance. And I think, yeah, of course, I can't do anything with it until we get access to it. But what I'm hoping is that these kind of projects at least make people aware that if everybody starts sharing their data, we can really do better research and get these synthesizing large scale sort of narratives, which hopefully will start, changing the mindset a little bit. Yeah, because I think quite often people are sort of secretive of the data because they're worried somebody might steal their ideas or something. And that's that's always, of course, an issue when you share stuff. But maybe another way to approach this is that also the search engine itself doesn't provide you with the full data, so you still have to go to the archive to get the data. It could be a similar way where people might have to personally ask for a report or sign a waiver or something. So there's always like an extra level of security or access restriction you can put on your data, but still upload it into here. And that might be a way of solving this to some extent. Yeah, maybe. But mainly it's about that sort of paradigm change of if we all share, we can all research better. Yeah.
You asked your question closer to Alex so that the audience can hear it.
Okay, right.
No, I was just thinking, so on the issue of translation, so that I have access to other languages. Is that on fly as soon as possible? Or does it have to be input? I mean, how frozen is the language when it reaches the end?
Yeah, it's a very good question. I didn't go into too much detail there. But so there's two ways you can do it. You can either do the translation during the indexing, so when you're actually processing these documents, or you can do it what's called at query time. So when people actually start typing, you can do the translation then. And I think the second option is preferable, because when indeed if a translation change, or even if somebody has a different definition of a translation, you can in theory fix that at query time. So what I think is more useful is indeed having people start typing something, and it will suggest, oh, you also mean this and this and this. So you can choose, oh no, I don't mean that, but I do mean this, and make some suggestions for this translation. And then, because then from the search side, it's very easy to just search for all these different terms at the same time. But it gives the user a little bit of control over both the translation and the semantic it's trying to do. Yeah.
It was on my mind because a package of Dutch cookies appeared in the stack.
No.
And there was instructions on the side, and the check on scalpel. Because the word was scalpel and plate or tray or something.
Wow. Yeah.
And of course, in detail, you can choose that.
Yeah. Yeah.
But if it was frozen in advance, you might
Yeah. Yeah, exactly. Yeah, and actually a similar problem with the time periods and how they're defined, because currently I use the same definition for all time periods in the Netherlands. So it doesn't matter if you're in the north or the south; it will be the same year range. But technically, that's not the case for stuff like the Neolithic, which starts earlier in the south than in the north. And some people might disagree on when the period starts. Ideally, you want to give the user complete control over what they mean with their search. But that then also requires extra work from the user to say, okay, well, I want to use the default settings, or I create my own, make some adjustments, and that should always be possible. Yeah, because indeed, if you hard code it into the index, then yeah, it's really hard to change it. You basically have to completely rerun everything, and that would be a shame. Yeah, yeah.
Possible. And just thinking of Felix release for, I just remember.
Yeah. Yeah. No, definitely. Yeah, yeah. Yeah, and then something I've not touched on yet, but we will need to think about at some point, especially if we expand this also. Time periods are different in different areas, of course. So, you know, in Germany, they might have a different definition, not just of what the Neolithic is, but also the time and also what and where. And that's just the problem with archaeological search in general and archaeological data. It's all fuzzy and subjective to some extent. We have some hard data, but not a lot of it. So it's, yeah, good points. Yeah.
I have a question from Julian.
All right. Yeah.
So it says, thanks, Alex. That was really interesting, particularly the different performance between the NER approaches in different languages. Do you know if there have been a comparison between languages in any other domains?
I know some people did this for Russian biomedical and English biomedical, named anti-recognition. And there they definitely showed that it was just a much harder task in Russian, but again, similar problems where the amount of Russian data available was probably the limiting factor there. So that's the only one I'm familiar with, but it's not done that much. I think in general, multilingual search is still not really hit the mainstream kind of thing. Also partly because a lot of this research is done on domains where everybody just speaks English. So biomedical domain is sort of the, yeah, one of the top contenders in this field, and they tend to all just write in English. So that makes it easy for them. But it also means that this multilingual aspect is not really investigated that much. I'm sure there are some more examples, but can't think of any at the top of my head. But there, yeah, Russian biomedical stuff was definitely a problem. Yeah.
Great. Another question from online is Holly. And Holly says, I'm curious about the impact of compound words in your work. As you're comparing languages, do you find that compound words make NER more difficult, or does it make it easier because there's less ambiguity about the relationships between words making up a compound word? I know German uses far more compound words than English. I'm not sure where Dutch falls on that continuum, but it would be interesting to know if the presence of more compound words make a difference in your results.
Yeah, that's exactly the problem we run into actually. So German uses compound nouns the most, like a lot. Dutch to some extent, and then English almost never. And so actually what I've learned also with this annotation setup is that I think I had like 5 questions in total over the total amount. When I did in Dutch, I got a question sort of every half an hour, and with Germany, it was every sort of 2 minutes there was a question. Because all these compound nouns make it really complicated, specifically for name entity recognition, it makes it very complicated. So in German, you might say Bronze Age axe, and it's one word. So then do you say well, you would say that's an artifact, of course, but it also contains information about the time period. So how would you annotate this? And these methods only work on a word basis, so you can't split them up. You could in theory do some tricky stuff, but this makes it very complicated. And then another thing we run into is that the way Germans write is sort of very archaic. I hope I don't offend anyone, but it's sort of the writing style is very much more complicated, which then also makes it more complicated one to understand and then to annotate as well. So the differences between languages are very clear, and I think also yeah, I didn't talk about this in the results table, but you could see that for German in general the results were lower than for Dutch, and then for English again slightly better. And so there's not just the effect of the amount of languages available to train on, but also the effect of the inherent difficulties of the language itself. And so yeah, these compound nouns are always a problem when we're doing linguistical stuff. Yeah, yeah, it's a really good question. Yeah.
Oh, I don't know if you're gonna really.
I'll repeat the question briefly.
Okay,
Yeah.
I was just wondering if you see the technology from like ChatGPT changing anything as you go forward with it.
Yes, the question was if ChatGPT will change what I'm doing here, and yeah. So at the moment, The main issue I'm dealing with is scalability. So to give you an idea, this bird model, to run it on my 80,000 documents took about 2 weeks. And that's running on 8 GPUs simultaneously. So it's a ridiculous amount of processing that needs to happen. And these ChatGPT models are, I believe, between like 100 and 1,000 times bigger in size of scale of the model, which then also directly translates to the compute time. So then we'd be running it for months or years potentially, unless I get more GPUs. Don't think we've got any investments coming up. So yeah, it will take too long basically to actually run it. And then of course, what we're also running into is these models get bigger. It's not just time, it's also the energy usage, the water to cool the servers. So, like there's an environmental impact and monetary impact to using these models. So currently, I don't think I'll be using it on the production side of things, actually in the search engine, until we magically get green energy and free GPUs. But I will be doing some experiments, at least see how much better would it get. And I think there's always with machine learning, you need to ask yourself, is that 1 or 2% increase in performance, is that worth the extra effort and power and everything required to run it? But it's good to at least have that answer, like how much better is it? So I definitely will be doing some small scale experiments and see how it works. Yeah. And then at the same time, there's a lot of people working on making these GPT models smaller, which means they're less effective, but they require less power. So that's really what I'm hoping for, is that we're going towards smaller models that can run more easily. Yeah.
Selfishly, do you see any creative responses to this? Do you see any ability for us to be creative within this sphere? Do you see anyone besides archaeologists using Agnes?
That's a very good question. So at the moment, so I don't track actually who's using it. It's all anonymous. So I'm not sure if people outside of archaeology are using it. But by looking at the logs of the queries, it's very much sort of archaeologists looking for their specific research thing. So I think at the moment it's still very much a research tool. But something we are looking into doing is there's going to be an exhibition on Bronze Age Netherlands in a museum close to our university. And we want to at least have a QR code or something that can lead the visitors to Agnes, and specifically to queries that are to do with the exhibition. So they will see some bronze swords and then can go into Agnes and say, okay, where are they? What's the context? What are the reports where these are mentioned? So there to get a little, well, maybe not creative, but at least get some non-archaeologists involved in what we're doing here. Yeah. Other than that, creative uses. I mean, you could probably do some cool visualizations of what's been found where, and because now we've got big data that you can do stuff with. So there's definitely opportunity, but not really dug into it yet. Yeah.
Yeah, it would be really great if your museum exhibit had a free text in a way, if you could just see what people would ask.
Yeah.
You know, it's like, well, if you can ask something, ask an archive, what would you ask it, and how would we be able to connect what Agnes can do with the needs of the public?
Yeah, exactly.
Can you do that? Let's just do that.
Yeah, I mean, yeah. Well, I can at least check what people who come from the museum that come in there and check what they are doing and have some response there. Actually, something I didn't mention about ChatGPT and these kind of models is that, so Agnes is very much built for professional search, so it's people who know what they're looking for. Well, the great thing about ChatGPT is that you can just talk to it. You don't have to formulate a query, you don't have to think about it, you can just speak it almost and it will understand. And I think that's really where we can make archaeology more accessible to general audience and get a bit more creative with it. And so a recent development in ChatGPT-like systems is that, I'm sure you're all familiar, that they hallucinate. So they come up with facts that don't exist, very confidently say that something is wrong. And so a recent trend is to basically plug in a search engine to the back end. And so when you start typing or ask something to ChatGPT, it will first check with the sources what is actually in there and then give you an answer back. And that's something I'd like to do in the future, where there's a chat interface with all of our documents. So you can ask, what kind of cups are found next to Roman graves or something, and it will actually start to give you an answer in words, instead of just showing you a list of documents. And I think that's where we can really involve non-archaeologists as well. Yeah, hopefully.
Fantastic. Thank you so much for coming today. And I think, unfortunately, for the online people, I think we might head to the pub. So
Yeah.
let's all give Alex a big round of applause. All right, people are thanking you. Thank you very much, Alex.
Quickly open the chat. Yeah.
Thank you, Rochelle.
Thanks everyone for joining online as well.